We have already discussed two types of classification methods in day 9, including decision tree induction and Bayesian classification. Now, using day 10, we are going to discuss more about classification techniques, and we will discuss some more techniques in this particular material. This particular material include rule-based classification, classification by backpropagation, support vector machines, associative classification, lazy learners, which are also known as learning from your neighbors. We will cover two such type of learners, k-nearest neighbor classifiers and case-based reasoning. We will also discuss some other classification methods, including genetic algorithms, rough set approach and fuzzy set approaches. First, we will discuss about rule-based classification. In rule-based classifiers, the learned model is represented as a set of if-then rules. If-then rules are used with the programming languages, and we can simply create rules using this particular format. These rules are then used for classification. There are two ways in which we can generate the rules. It can be either from a decision tree or directly from the training data using a sequential covering algorithm. Using if-then rules for classification. Rules are a good way of representing information or bits of knowledge. A rule-based classifier uses a set of if-then rules for classification. An if-then rule is an expression of the form if condition then conclusion. We can see an example, rule 1. If age equal to youth and student equal to yes, then bias computer equal to yes. This is the same example we are discussing about. The if part, or the left hand side of a rule, is known as the rule antecedent or precondition, which consists of one or more attributes. The then part, or the right hand side, is the rule consequent, which contains a class prediction. The rule can also be written as age equal to youth and student equal to yes implies bias computer yes, as we discussed earlier. So rule can be represented like this also. Now we will discuss about two measures, coverage and accuracy. These are used to assess a rule. A rule R can be assessed by its coverage and accuracy. Given a tuple X from a class label dataset D, let n covers be the number of tuples covered by that particular rule, n correct be the number of tuples correctly classified by this rule, and mod D be the number of tuples in D, that is the total number of tuples in the dataset. We can define the coverage and accuracy of rule R using the following equations. Coverage equal to n covers divided by mod D. N covers is the number of tuples covered by R divided by the total number of tuples. Accuracy equal to n correct divided by n covers. That is the number of tuples that are correctly classified by R divided by the number of tuples covered by R. That is, a rule's coverage is the percentage of tuples that are covered by the rule, that is, whose attribute values hold true for the rule's antecedent. For a rule's accuracy, we look at the tuples that it covers and see what percentage of them the rule can correctly classify. So these are the two measures for assessing a particular rule. We have seen there are two methods for generating rules. The first one is rule extraction from a decision tree. We are familiar with a decision tree as shown here and how we can represent rules using if-then format. In comparison with a decision tree, the if-then rules may be easier for humans to understand, particularly if the decision tree is very large. To extract rules from a decision tree, one rule is created for each path from the root to a leaf node. Each splitting criterion along a given path is logically AND to form the rule antecedent, that is the if part. The leaf node holds the class prediction forming the rule consequent, that is the then part. We will see how this can be represented. This is an example for extracting classification rules from a decision tree. Here the rule 1 represents if age equal to youth and student equal to no, then bias computer no. So we are generating first rule, and the second rule R2 says that if age equal to youth and student equal to yes, then bias computer yes. And we can represent the other rules R3, R4 and R5 from this particular example. So this is the way we can generate rules from a decision tree. The second method that we can use for generating rules is rule induction using a sequential covering algorithm. If-then rules can be extracted directly from the training data using a sequential covering algorithm. The name comes from the notion that the rules are learned sequentially, that is one at a time, where each rule for a given class will ideally cover many of the tuples of that class. Therefore, the name sequential covering algorithm. These are the most widely used approach to mining disjunctive sets of classification rules. Classification rules can also be generated using associative classification algorithms that we are going to discuss in the further slides, which search for attribute value pairs that occur frequently in the data. There are many sequential covering algorithms. Popular variations include AQ, CN2, and RIPPER. RIPPER stands for repeated incremental pruning to produce error reduction. These are the various sequential algorithms, sequential covering algorithms that we can use. The general strategy is as follows. Rules are learned at one at a time. Each time a rule is learned, the tuples covered by the rule are removed and the process repeats on the remaining tuples. This is a simple algorithm, therefore I put here in this particular slide. You can understand the algorithm easily. We have input, that is the data set, class label tuples and attribute values, and we will get a set of if-then rules. That is we are generating rules. The method is initially the rule set is empty, and for each class C we are repeating some steps, that is we are calling a procedure that is known as learn one rule, which finds the best rule for the current class given the current set of training tuples. So we are generating a particular rule, and we will remove tuples covered by this particular rule from D until terminating condition, and the rule set will be incremented with this particular rule and we will return the rule set. So this is the basic sequential covering algorithm. Now we will see how we can choose best rules using the measure that we have already discussed, that are accuracy and coverage. We will see one example. Consider the two rules as illustrated in figure. We have two rules R1 and R2, which are separated using the dotted lines. Both are for the class loan decision, that is equal to accept. A is used to represent the tuples of class accept, and small r is used for the tuples of class reject. So A and R are used here in rules R1 and R2, which represent accept or reject. Rule R1 correctly classifies 38 of the 40 tuples it covers. Actually, the rule R1 covers 40 tuples in total, and among that 38 tuples are correctly classified. Here in rule 2, it covers only 2 tuples, which it correctly classifies, but all the tuples are correctly classified. Their respective accuracies are calculated as 95% and 100%. That is, R1 is having 38 by 40 correctly classified, or the accuracy is measured like that using the previous equations, and it is having 95%, and R2 is having 100% accuracy. Thus, R2 has greater accuracy than R1, but it is not the better rule because it covers small coverage. So we can't predict that whether it provides high accuracy, that rule will be the better one. We have to check with the other condition also, that is the coverage. Here R1 covers more tuples, therefore R1 is the better rule here. Other measures for evaluating rule quality include entropy based on information gain and statistical test that considers coverage. Different algorithms use different methods for evaluating the rule's quality. CN2 uses entropy together with the likelihood ratio test, while FOIL's information gain is used by Ripper algorithm. Rule pruning is also desirable to improve the performance of the rule. As in decision tree pruning, we refer to this set as a pruning set. Various strategies can be used, such as the pessimistic pruning approach, foil prune method, etc. So these are the points related with the rule-based classification.